Hello everyone, my name is Avin and today I'll be showing you how to put your deep learning or machine learning models into production using Panini AI. So there are a lot of resources online teaching us how to train our deep learning or machine learning model, but when it comes to actually putting these models into production, it's not really straightforward and there are many different options and it's very confusing. So we've created Panini and Panini is supposed to make it a lot easier. So the way it works is that you train your model wherever you want to, and you go to Panini and you just upload your weight, your pre-trained weights and parameters into Panini.ai, and Panini.ai will provide you with a API key where you can make a post request and you can start inferring your model from your JavaScript or your front end or your apps or whatever it may be. So let's get started. I have this little Jupyter Notebook demo that I have created, and in today's video, we're going to show how do we upload this classic dogs versus cats dataset from Kaggle competition to classify pictures of dogs as if a picture is a picture of a dog or as if a picture of a cat. Okay. So the traditional approach is something like where you train your model and you use Flask to expose it to the internet, and for the process management, you'll use something like GUnicorn, and you'll wrap that with Nginx and put it in a Docker container. This process will work, but it's not efficient because Flask is very slow and it's not meant to serve deep learning or machine learning models. It's meant to serve just normal HTTP pages, right? So uh, and also just setting this entire thing up with the different configurations and making this entire thing work is quite complicated. And the first time I tried doing this entire Flask with GUnicorn, Nginx, and Ubuntu, it took me quite some time, and scaling is even harder. So let's get started. So very first thing is download the dataset from Dogs versus Cats dataset from Kaggle. And the requirements that you need in order to use Panini is that you only need Python 3.6. So make sure that you are training your model and saving it using Python 3.6. And this PyTorch 1.0, that's only needed if you're using the PyTorch framework, but that's not the mandatory requirement. But in this video, since we are using PyTorch, we'll be using PyTorch 1.0. Okay? So I'm gonna run with these boiler codes really fast because this is really straightforward stuff, and there are a lot of resources online teaching you what's happening. But pretty much over here, I'm importing Torch, and in this directory, I have cat and dog images, and these are different transforms that I'm applying. We'll be using DenseNet 121 to do the classification, and we'll be modifying the last layer of DenseNet 121 to do some transfer learning. Okay, so over here, I'm going to download the DenseNet 121, and this is what the model looks like. The model output has 1,000 different features. We're going to modify this last layer from 2,000. We're going to make it into 2 because we wanted to train if it's a picture of a dog or a cat. Okay, and that's where it's happening. Over here, model.classifier, I'm just changing this from 1024 to, rather than 1000, I'm just making it 256, adding a ReLU, adding a dropout, and from there, from 256, I'm making into only 2. 2, that's because if it's a picture of a dog or a picture of a cat, okay? This code over here is where the actual training is happening. I've already trained the model beforehand just to save time. It took me about 15-20 minutes in a GPU. Shouldn't take too long, so if you're interested, you can retrain the model, or you can just save them, get the pre-trained model that I'll be providing you on GitHub. So over here, once the model is trained, I'm saving it right over here as a file called lastlayers.pth, and I'm going to load this back again to my model. Okay. Now, that's done. Let's start actually doing some inferring it. So in order to infer it, over here I just have a picture of a dog. And I'm going to put this picture of a dog into my model. So we're going to do some forward pass into the model. That's what my model will return back to me. And over here it says that this picture over here is of a dog with a probability of 88%. Okay, so I've trained my model, it's inferring, it's working. Now I want to put this up into the cloud for production, right? So finally, let's use Panini.ai. So when you want to upload your code into Panini.ai, there's a few things that you need. Okay, there's 3 things that you need to upload. You need to upload into Panini.ai. First thing that you need to upload into Panini.ai is your trained parameters, which is that last layers.pth that I was telling you about. The next thing that you need is a file called requirements.txt, which is where all of your pip packages should be mentioned if you want to install additional packages like NumPy and pandas. And the third thing that you need is a file called predict.py. Okay? So this predict.py file should have two different functions inside of it. The very first function that it should have is called load, and the second function that it needs to have is called predict. Okay? This load function gets executed only the very first time your model gets loaded up into Panini's backend, and needs to have a parameter as path. Okay? And you need to define your entire architecture again over here inside this load function, and you'll be using this load.stateDict to assign those pre-calculated weight that you got during the train process. In this case, that was lastlayers.pth back again to our model, and it will be returning the model. The predict function gets executed whenever a client sends a post request in that URL with that API key. Okay, and again, the very first thing that you need to do is do all of your imports. The second thing is preprocesses such as transforms.compose. The third thing is whenever a client sends you let's say an image, it's coming over here in this variable called input from client. But this input from client is actually a list, Python list. Even if a client only sends you one image or 100 images, it's still a list. So what I'm going to do is I'm going to write a for loop and convert each of these images into a tensor, and we're gonna forward pass it into our model, and it's gonna return the output. Okay, so over here, like I said, three things that we need: requirements.txt. In this case, I only need NumPy, so I only have NumPy over here in this file. Next thing that I need is predict.py, and the third thing that I need is lastlayers.pth, which is the pre-trained thing, weights. So load function, that's the one that gets executed the very first time. I'm doing all of my imports right over here. I'm defining the model architecture right over here. So in this case, I'm just downloading the DenseNet 121. I'm freezing up all these things, all of the, so we don't backwards propagate through it. Over here, I'm modifying it so the last layer is only 2 rather than 1000. And I am loading up my weights, which is from lastlayers.pth. And where is that file, lastlayers.pth? It's in this predefined folder called path, which is right over here, right? Make sure your map location is set to CPU. And this function should return model. Now, the predict function has all of our import statements over here, okay? Then it has the preprocesses, which is what kind of preprocess that I want to do when an input comes in. So when an image comes in, I want to resize it, I want to crop it, I want to convert it into a tensor, then I want to normalize it. So these things are done over here. Okay. So like I said, the image comes in a form of a list. So I'm going to have a for loop. Then I'll be applying these preprocesses and converting into tensor and just like sizing the tensor. Now, the picture that came as an input image client, it's now an image tensor. Now I'm going to do forward pass in this model, and it's going to return me log probability. After it returns me log probability, I'm just doing a few additional stuff to return this string called cat probability, and the probability, if the class is 0, if it's 1, then it's dot probability with a dot probability. But you can't just return the string value, return label. The reason for that is, as return label is just a string, the value that predict needs to return has to be a list, okay? And the length of that list must be equal to the length of the final layer in the model. What do I mean by that? Our model, as you can see, it's returning a tensor or a list of tensor, and it's 2. Because it's going to give us a probability of a dog or a cat, right? Like the first one will be the probability of a cat, comma, the next one will be the probability of a dog. So the predict needs to also return a list with the length of 2. Okay, so over here I'm just pretty much converting, I guess, my string and assigning it as a list. But since it only has a length of 1, I'm just adding this dummy value of 1 over here to make this equal. The return label's length equals to 2. Okay, this is very important. If you don't do this, it won't work. And I'm going to return the label. So with these 3 files, I'm going to go to panini.ai, let's log in, I already signed up, so it's going to take me to my dashboard. Now, this is where I will upload all of my files, okay? So I'm going to give my model a name. So let me call it cat dog, okay? Any name. Just make sure the name is less than 10 characters. It has to be A to Z and 0 to 9. Framework, I'm going to choose as PyTorch, but you can choose Python function if you are doing like classical machine learning, like SVM, regression, and stuff like that. And if you're using FastAI library, you can choose FastAI. The input type, I need to define what kind of input is my model expecting. Since we are sending an image, it's being encoded as a base 64 before we send it. I'm going to show to you how that works a bit later. So we'll be using bytes. Okay. Now I'm going to click on Browse. These are my 3 files that I was talking about that I showed you. Click on Open, and it's going to upload it. Now this additional thing that we see, choose extra files, optional. This is not really needed. It's not mandatory. This is needed when, let's say, if you have a RNN, and a lot of times in RNN we have an extra file called something like vocab to int, which pretty much converts each of the vocabularies in your RNN model for like the sentiment analysis into an integer. That does this, it just does the mapping. So if you do have some sort of additional files, then you would just upload it over here, but since we don't have it in this case, we won't. Now, I'm just going to go ahead and click on deploy. When I press deploy, it takes a few minutes for the model, for Panini to actually take your code. It will put it into a Docker container, make sure everything is good to go. Then after that, we'll push it back into our Kubernetes cluster and so on. Okay. At the bottom over here, I mean, you can already see some of the output, but that's from a previous model that I uploaded. If I want to see the output, all I need to do is just refresh the page. Okay. So after this is done, this you see 100% being shown. You can just go ahead and refresh the page. When you refresh the page, this log output will get refreshed. Okay, and as you can see, there are a bunch of things being shown. The very first one is it created a Docker container for us. It successfully built a Docker container. It's saying that pushing your model image to Kubernetes cluster, so it's actually now pushing it into Kubernetes cluster for us. So wait a few more minutes. It doesn't take more than 3, 4, sometimes maybe 5 minutes max. And if everything works out, we should get an API key over here that we can use to infer. So bam, we got the API key. If we scroll further down, the very last message that you should get over here would be something like done deploying your model, you're good to go. And it gave us an API key. Now, we can just copy this API key and we can start inferring our model. So how do we do that? I'll be just showing you how to do this using the Python request. So simply Python request allows you to make a request to a given URL. So I'm going to go ahead and it will be post request, and I'm going to delete this link and copy this. The header has to be content type with application JSON. The data is the picture of a cat, and I'm going to read it, and I'll be encoding it as base 64, and make sure the input for the JSON has to be input, the word input, and I'm going to encapsulate this as a JSON format, and I'm going to send it, okay? So that's done. I'm going to go ahead, press enter. And if we wait for a bit, it's talking with the Panini's backend, and it got back to us saying output with the cat, probability of 99%. Now, let me just do it again. Notice how the second time it ran a lot faster than the first time. The reason for that is it's already doing all this caching mechanism in the backend. So if a certain data is already showing or already someone entered, it won't actually go out there and recalculate it and do an entire forward pass into your model. It will just show you the answer. Okay. We can even do this just using a Postman just for the sake of it. So let me just go ahead and enter that URL into the Postman. Header is content type application JSON. In body, I'm going to I made the base 64 encoding automatically. And if I were to press send, I should get a output. Let's just do pretty right here. So this picture apparently was a picture of a cat, and it's really sure it's a picture of a cat because it's 100%. So yeah, this is how you deploy your model into Panini. If you have any questions, please contact me. I will reply back really, really fast. If you're having trouble with uploading your model, we can get in touch. I can guide you through the entire process, or you can send me your model and I can upload it in behalf of you. So yeah, let me know what you guys think about it, and hopefully you found this video really helpful. Thank you.